Hello, my name is Valentin Bura, and previously I have managed to settle the Riemann hypothesis in a paper titled On the Sum of Divisors and the Robbins Theorem. Today, I'm going to run you through my proof of the collapse of the polynomial hierarchy, summarized in a paper entitled Positive 1 in 3 set admits a non-trivial kernel. So, let's get to work. Positive 1 in 3 set admits a non-trivial kernel. This is a linear algebra paper. We make use of Gaussian elimination and substitution, though we don't make use of these methods at the same time. These methods are interchangeable. So we make use of these methods in order to settle the problem of the collapse of the polynomial hierarchy. We apply these methods to the problem of exact Boolean satisfiability, also known as 1 in 3 set. For 1 in 3 set with non-negated literals, we are able to obtain considerably smaller equivalent instances of the integer programming problem, restricted to equality only. So this is Boolean integer programming, 0-1 integer programming, restricted to equality only. Both Gaussian elimination and substitution may be used in a processing step, followed by a type of brute force approach on the kernel thus obtained. What we propose in this paper is a simple, very simple pre-processing step, followed by a brute force search on the obtained kernel. It is called a kernel because it is some sort of a compression. It is a compression of the problem instance, hence the terminology kernel. So the method shows that positive instances of 1 in 3 set may be reduced to significantly smaller instances of integer programming with equality in the following sense. Any such instance of v variables and c clauses can be polynomial time reduced to an instance of the integer programming problem with equality only of size at most 2/3 of the number of variables and at most c clauses. We obtain an upper bound for the complexity of counting, the associated counting problem, yes. And we proceed to define formally the notion of a non-trivial kernel, defining the problems considered as constraint satisfaction problems. We conclude by showing the methods presented here, giving a non-trivial kernel for positive 1 in 3 set, implied the existence of a non-trivial kernel for 1 in 3 set. Okay. This paper was written in, the final version of this paper was written in June 2019 in Bucharest, under the impression of a very beautiful song. From memory, this may not be accurate. However, from memory, I was listening to a beautiful song called